All right, in this video, we're going to talk about resolving vectors. Let's imagine that in Chicago, they're filming a new movie, and this is in the movie, there's an airplane, and the airplane's flying at an angle of 20 degrees to the ground, so the truck that has the camera has to stay under the plane as the plane is flying. So the question is, from a physicist standpoint, what speed does the truck need to take to keep up with the plane? Well, you might realize that it's not actually the speed of the plane that the truck has to have. What the truck has to have is just be equal to the speed of the plane in the x direction. So this is the x direction, is horizontal. The plane is also going in the y direction, right? Because the plane is going up. It's going up at the same time it's going over. The y direction doesn't matter. It's just the x direction. So how could a physicist find the x direction velocity of this plane? Well, if you look down here, we're going to practice a type of math called vector composition. So what that is taking a resultant vector and finding the two components, the x and the y. Here's the x, here's the y. It's the opposite of what we've been doing. We've been given the x and the y and been finding the resultant. But if you have the resultant and you want to find the x and the y, how do you do it? So let's take this and find out. If you remember from the last video, we talked about SOHCAHTOA. So I'm going to write SOHCAHTOA up here. And here we can see the equations for SOHCAHTOA. And we're going to apply SOHCAHTOA to this triangle to find v sub x. So the way you show the velocity in the x direction is with a v and then a subscript x, showing the horizontal component, and then you show v sub y for the vertical component. So this side, for this angle, this is the opposite side, right? So this is O, and this is A, and here is our hypotenuse. So our first step is to find Vx. So what we're going to do is apply, we have the A and H, right? We want to find the adjacent side, so we're going to use cosine to find the x value. So plugging everything into this equation here, cosine of the angle is cosine of 20. So we'll do, here, let's do this in blue. So we do cosine of 20 equals the adjacent side, so that's our x, or v sub x, over the hypotenuse, right, using this equation. So the hypotenuse here is 95 kilometers per hour. And we can solve this for x, right? We can multiply 95 to this side. We can find cosine of 20. And we get for this Vx, v sub x is equal to 90 kilometers per hour. So the truck only has to go 90 kilometers per hour because that's the velocity of the plane in the x direction. It doesn't have to go 95 kilometers per hour, which is the speed of the plane in this direction. All right, so let's try this practice problem. This is from your book. This is from the book page 91. So if you want to look in your book, you can kind of follow along here on this. So it says, find the components of the velocity of a helicopter traveling 95 kilometers per hour at an angle of 35 degrees to the ground. So I'm first going to draw my picture. Whoops. So I'm going to draw my velocity vector of the helicopter. So here's the helicopter's velocity vector, right? And this is 95 kilometers per hour. And I also know if I draw the ground here, we'll draw the ground here. I know this angle is 35 degrees. Okay, so we've got this vector of 95. We've got the angle of 35 degrees. Find the x and y components. So it says find the components. So we need to find the x and the y. So I'm going to draw those in. I'll do them in red and black. So the y component, this is right here. This is v subscript y. And we'll do the x component in blue. So this is v sub x. So to find v sub x, we have right now, this is the adjacent side, and we have the angle and the hypotenuse, so we're going to use cosine. So to find v sub x, we do cosine of 35, and then multiply that by the hypotenuse, which is 95 kilometers per hour, and we get, and we can now multiply those together, and we get a v sub x is equal to, and we get 78 kilometers per hour for v sub x. Okay, so for v sub y, again, I'm going to look at my triangle. I want to find the y side, so I use this is opposite over adjacent, so TOA I can use, I can use sine of 35 equals opposite over hypotenuse. So we'll do that in red, so that's going to be Vy is equal to the sine of 35 times 95 kilometers per hour. And we solve that for Vy, and we end up with a Vy is equal to 54. Oh, I got weird there. 54 kilometers per hour. Okay, so again, we're using cosine. Normally is used to find the x component, and sine is normally used to find the y component. This is how you do it. So if you have any trouble, let me know. And physics is fun.